Okay, I'm going to talk now about Green's theorem, which is the second version of the fundamental theorem of calculus in higher dimensions. So Green's theorem is a fundamental theorem of calculus in 2D, and you can think of it as relating area integrals to line integrals. Similar to how the fundamental theorem of calculus in 1D, or for line integrals, it related line integrals, or in other words, or simply the integral from a to b, to sums, or really just f of x evaluated from a to b, and these can be vector quantities in three-dimensional case. So you can call this a 1D integral, and this is a zero-dimensional integral. Now, let me just state what Green's theorem actually is. So it says that if you have an integral over a closed curve, and it's your vector field, then this is actually the same thing as the integral over the area and region enclosed by that curve. Let me just draw out R and C. And the integrand, when you're integrating against dA, it'll be qx minus py. So f, of course, is just, we're going to call it pq. These are the components. And qx is the partial derivative with respect to x, because we are lazy. So what this is saying, is that this is a 1D line integral, and it's related now to a 2D surface integral. And the point is, why do we have this form of the integrand? So y qx minus py. The reason is because it is equal to 0 if f is a gradient. Why? And remember, why is this important? It's because we know that the integral over a closed curve of a gradient is equal to 0, because it's just f of b minus f of b. Because b is the same thing, right? If you have a closed curve. B is the same thing as a. If it's closed. And that's what this circle notation here means. It just means closed curve. And it's like a circle. And hence why it's a circle integral. So remember that a gradient is just fx, fy. So surely if that's p and that's q, then qx will equal py. And these will both just be x, x, y. So that's 0. And this is 0. So in general, we think of qx minus py, it measures how non-conservative f is. And this is related, and it satisfies the fundamental theorem of calculus. And let me just make one more remark. The curve is positively oriented. And that just means counterclockwise. Right? So if you have a circle, we choose the counterclockwise orientation. This is the positive one. On the other hand, if our curve was going in the opposite direction, clockwise, we would call this negatively oriented. So in this case, if we do an integral and it's counterclockwise, it would actually be equal to minus the it would be minus the integral with the opposite orientation. So you just have to keep which one straight. And so Green's theorem works for positive. And if you have negative, add a minus sign to change to positive. So that you can use Green's theorem. Okay, so I'm just telling you to keep the minus sign straight. Okay, so let me stop right here, and in the next video I'll tell you why Green's theorem actually works.